Hi guys, welcome to another physics video. In this case we have the velocity versus time graph. If you remember in the previous video we worked with the position versus time. Okay, so now in this case we got this graph and we are going to see kind of the same concepts, but of course some things are gonna be different. For example, the first thing that I'm going to do is that I'm going to separate the segments, just as the previous video. Remember that in this case, I'm gonna have three different lines. That is the horizontal line, the line that goes upwards, and the line that goes downwards. Okay, so I'm going to separate those different lines here in the graph. So for example, you see I got this horizontal line and then I go upwards. So this will be a segment that I'm going to separate. So goes upwards and then horizontal. So then this is another segment. And then horizontal and then goes upwards again. This is another segment. And then upwards, downwards, this is another segment that I'm going to separate. And this is another one. This is horizontal and then goes downwards. And then downwards and then horizontal. Well, I cannot separate here, but I'm gonna do it here above. Just like this. Okay, and then goes upwards. I'm going to separate here and then horizontal, and I'm going to separate here. Oops. Just like that. Now with another color I'm gonna name the segments. This is the segment number 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so there are many things that we can work with this graph. So if you see, this is velocity versus time. So here we have the time and here we got the velocity. So if you see, the motion begins here at 0 seconds. 0 seconds is here. So let's say that this is an object. It will be, I don't know, let's say that this is a car. So in the second 0 seconds, the car is moving at 2 meters per second and then increases its velocity up to 5 meters per second, and then it's going to remain there for 2 seconds, and then increases velocity and immediately decreases velocity up to 2 meters per second, and is going to remain there for 1 second, and then decreases the velocity up to 0 meters per second. I'm gonna write here 0, and then increases the velocity. Is going to remain here for 1 second, and then increases the velocity up to 2 seconds, and is going to start to 2 meters per second, and then is going to stay over there for 1 second. Okay, so if you see, I can ask, what is the only segment where the car is not moving? Okay, so for example, if we do exactly the same as the previous graph, when we said that the horizontal line means no motion, we can say that, okay, in segment number 1, 3, 6, and 8 and 10, the car is not moving. But this is not true, because for example, if we see the segment number 3 that in which we have the horizontal line, the car is moving at 5 meters per second. So in order to the object to be still, the velocity must be 0 meters per second. So that is not the case for this one. So if you see the whole travel, the whole motion, we're going to have velocity. So the car is going to move, except in the segment number 8, because if you see, the velocity is 0 second. So that's one important thing to keep in mind, that the only segment that where the car is not moving is in the segment number 8. Okay, So let's see the definitions of the what does it mean to have an horizontal line. So to have an horizontal line means constant velocity. Constant velocity. So that means that the velocity is not going to change. So that means the acceleration equals 0 meters per second square. Okay, and that means that I'm going to have ULM, that is uniform linear motion. So that means that is uniform, it's not going to change. But if we have a line that goes upwards or downwards without inclination, well, that means that I have a change in velocity, the velocity change. So for example, here the velocity increased from 2 meters per second up to 5 meters per second. So that means that the velocity changed. So if there is a change in velocity, that means that we're going to have acceleration. So I'm going to have acceleration here. If goes up, the acceleration will be positive. If goes down, the acceleration will be negative. Okay? Because there is a change in velocity, we're going to have acceleration. And this motion is called accelerated uniformly linear motion. Okay, so those are the two different types of motions that we are going to have. Okay, the constant velocity and the one that has acceleration, and the acceleration could be positive or it could be negative. Okay, so for example, I can write that this is ULM. I mean, I'm just gonna write here ULM, uniform linear motion. Remember, that means constant velocity. ULM. You might say, oh, but in segment number 8 I have no velocity. That's correct, but it's constant. It's 0 meters per second. The velocity remains. That's why it's ULM, and this one is ULM also. Okay, so the others, I'm gonna have acceleration, so it's going to be accelerated uniformly linear motion. Okay, so there are several things that I'm going to find in this graph. So for example, I'm going to find the acceleration in each segment. Okay, the acceleration in each one of the segments. So right here below, I'm going to write the formula that I'm going to use to find the acceleration. So acceleration equals the final velocity minus the initial velocity over final time minus initial time. Okay, this formula is very important, so I'm going to circle it. Okay, so I'm going to write all the segments. Where can I write them? I'm going to write them over here. Okay, so the acceleration of the segment number 1 is, as I said, is horizontal line, so that means constant velocity. That means that the acceleration is 0 meters per second square. Okay, what about the acceleration of the segment number 2? Okay, so let's find it. Every segment has 2 points, final point and initial point. This is the final and this is the initial. Okay, so I'm going to substitute the values here for segment number 2. So the velocity for the final point of the segment number 2 is 5 meters per second. So 5 meters per second minus 2 meters per second, because that's the value of the velocity in the initial point, over the value of the time in the final point, that is going to be 3 seconds, minus the value of the time here is going to be 2 seconds. So this is going to be 5 minus 2, 3 meters per second over 1 second. So the answer will be, I'm going to write the answer over here. that is going to be 3 meters per second square. So that means that object increases its velocity 3 meters per second each second. I repeat, that object increases its velocity 3 meters per second each second. So then I'm gonna write the acceleration of the segment number 3, that is 0 meters per second square because it's an horizontal line. The acceleration of the segment number 4, and I'm gonna do it in the calculator so I don't have to write all the procedures. So segment number 4 is here, so the final point is fraction 7. This is the final point, the velocity is 7 minus the initial point. This is the initial point of the segment number 4, that is 5, over the time. The time in the final point is 6 minus 5. This is the initial point, that is 5. This is 2 meters per second square. Okay, 2 meters per second square. Okay, the acceleration of the segment number 5 and goes downwards, so that means that it's going to be negative. Remember, the final point, I'm gonna write the final point. This is the final point and this is the initial point. I don't know if I told you, but I recommend you the final point to be always the one that is at the right. I repeat, the final point always the one that is at the right. Okay, so the acceleration of the segment number 5 will be 2 meters per second minus 7 meters per second over 7 minus 6 seconds. And how much is that? Minus 5. Okay, so that means that this car increases its velocity minus 5 meters per second each second. Okay, so this is going to be minus, let's change the color, minus 5 meters per second square. Okay, and then I'm going to write the acceleration of the segment number 6 is 0 because it's an horizontal line. Now the acceleration of the segment number 7, the acceleration of the segment number 7. Okay, let's see it. This is the final point and this is the initial point. So, and it's going to be negative because it goes downwards. So the velocity is 0 minus 2. Okay, over 9 minus 8. 9 minus 8. So this is minus 2 meters per second square. Okay, the acceleration of the segment number 8 is horizontal, so that means 0 meters per second square. 9, the acceleration of the segment number 9 equals, let's see, the velocity of this point is 2 minus 0 over 11 minus 10. 11 minus 10. And that is 2 meters per second square. And finally, the acceleration of the segment number 10 is 0 meters per second square. Okay, now I got the acceleration of each one of the segments. Now I'm going to find the total distance traveled. Total distance travel. But in order to find the total distance travel, I need to find the distance travel for each one of the segments. So let's say the segment number 1. The distance of the segment number 1 equals the area of the segment. Okay, so in this case it depends on the figure that we have. In this case we got a rectangle, okay, a square. and the area, the formula will be base times the height. Okay, so in this case will be 2 seconds, the base is 2 seconds, times the height, that is 2 meters per second square. 2 meters per second, sorry, 2 meters per second. So I'm gonna cancel seconds with seconds, so the distance traveled in the segment number 1 will be 4 meters. Okay, and I'm gonna write that that information, I'm gonna write it here, 4 meters. Okay, in the segment number 1 the distance is 4 meters. Okay, in the segment number 2, if you see, we got a strange figure. So what I'm going to do, I'm going to separate this one into 2 figures, and I'm gonna do it in the calculator directly. So the distance of the segment number 2 will be the area of this figure plus the area of this figure. So this one is a rectangle, that is going to be the base, that is 1 times the height times 2. Okay, plus the area is, the figure is a triangle, so it will be base times height over 2. So the base is 1 times the height is 5 minus 2, that is going to be 3 meters per second over 2. Okay, the height is 1, 2, 3. Okay, so equals 7 over 2, 3.5. So I'm gonna write here 3.5 meters. This is going to be meters. Now the distance of the segment number 3 is the base 2 times the height. How much is the height? 2 times 5. Okay, 2 times 5 equals 10 meters. So this one is 10 meters. And then this is going to be exactly the same as the segment number 2. I mean the same procedure, not the same answer. So the area of the rectangle will be 1 times the height, that is going to be 5, plus is a triangle, so the base is going to be 1 times the height is going to be 2 over 2. How much is that? 6. Okay, this is 6 meters. And segment number 5 is going to do exactly the same. I'm going to separate. So first I'm going to find the area of the little rectangle. That is going to be, the base is 1. Base is 1 and the height is 2. 1 times 2 plus, and then I have a triangle. The base is 1 times the height. 1, 2, 3, 4, 5. 5 over 2. Okay, how much is that? That is 4 meters. 4 meters. Let's see, the segment number 6 is the base. Base times the height, that is 2. 1 times 2 is 2 meters. The segment number 7 is 1 times the height times 2 over 2, because it's a triangle, so it's going to be 1. Here is 1. Here is 0, because it didn't move. Is that clear? It didn't move. Okay, so it didn't travel anything, so this is 0. If you see the acceleration, and it's going to be the same figure, segment number 7 and segment number 9 are gonna be exactly the same. 1 times 2 over 2, that is 1, and this one is 1 times 2 is gonna be 2. Okay, so the last thing that I'm going to do, I'm going to add them all. So it's gonna be 4 plus 3.5 plus 10 plus 6 plus 4 plus 2 plus 1 plus 0, I'm not gonna write it, plus 1 and plus 2 equals how much? 33.5 5 meters. Total distance traveled equals 33.5 meters. Remember that the distance is not a vector, it's a scalar. So the only thing that I care is its magnitude. Okay. Well, this was the example of a graph of velocity versus time. I hope everything is clear. I mean, this is constant velocity. The horizontal line means constant velocity. And if we got an inclination, well, in that case, it will be an increase or decrease in velocity. So that is a change in velocity. If we got a change in velocity, that means that I have acceleration. Okay. So stay tuned, guys, for more videos of Physics 2. Bye bye.